The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we've initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of this session is building high-performance web applications. Our guest speaker today is Amol Prakash Rao Patil. He's a Senior Manager Product Development. Amol has over 8 years of experience in web, mobile, desktop, hybrid application development, hands-on experience in building next-generation enterprise and consumer products in classic and emerging domains. He has also managed multiple simultaneous programs, mentoring, hiring geographically distributed teams. So we expect this webinar to last for about an hour with 45 minutes of presentation and the remainder time for Q&A round. So if you have any questions, please submit them using your questions tab on your GoToMeeting control panel. So without further delay, I introduce you all to our guest speaker. Over to you, Amol.
Thanks, Deepika. All right, let's start. So, hello everyone, good afternoon. My name is Amol Patil. I'm working as a Senior Manager Product Development at Claris Technologies. Topic of today's webinar is building high-performance web application. In today's seminar, we will cover following topics. We will cover benefits of web performance optimization. We will cover how and where to improve performance. We will go through the consideration for front-end optimization and different tools and optimization techniques. Similarly, we'll go through back-end optimization techniques and different references. Okay, so human perception of performance is very subjective. So first of all, let's understand how user sees a particular web application. How our brain works, and why building a high-performance web application is very essential for end users. So if a web application is very slow, it acts like a speed breaker for human brain. What happens as per studies is 57% of online consumers abandon their website if web page is slow. After 3 seconds they will abandon their web page. Also, it will lead to a concentration problem for end users. How brain reacts to a page load time is something which is illustrated in this diagram. So if it is if the response is in 100 milliseconds, that is 0.1 second, it feels very instantaneous. And if it is 1 second, it will let you think without any interruption. But if it is going to take 10 seconds, right, it will just about to hold your attention, and if it goes beyond that, the user will start losing interest in a particular website. So it all depends on how our brain works, or how our gray cells react to a particular visual memory or iconic memory. So for end user to get consistent experience, for him to retain his concentration on a particular web page, it's really essential that we should have a high performance web application which will load pages very fast within 10 seconds. It adversely affect end user as well. It will adds to its stress and anger, and many of users, like 4% of users, have changed their phones because of slow websites, like web pages are not at all loading on their phone. So that's why there is a need for high-performance web application to provide a good user experience, and having a good user experience is directly related to the profit which is generated out of that particular website. So faster webs mean better user experience, and then that leads to a huge profit. And if you look at different statistics, as I mentioned, that 50% of online user abandon site after 3 seconds. 80% of these people will not return to site at all, and half of these people will go and tell others. That gives a negative impression about web application website. So that's how it is impacting all over the web application performance impacts users as well as the profit for the organization. These are some of the stats, recent stats. Google lost 20% of revenue and traffic due to 0.5 seconds of delay in the page load time. 100 milliseconds of additional page load time decreased the sales by 1% of Amazon. So Amazon deals in millions, and 1% is quite a significant amount. So slow pages correlates to 3 million loss in e-commerce sales for US every year. So performance of the website is one of the key performance indicator for sales as well as brand experience. In addition to that, performance also is very essential for having a good search ranking. So all the search websites like Yahoo, Google use performance or site speed as one of the criteria to sort results. So if your website is very fast, it will appear higher in the search ranking of Google. So again, I mean, then it will reach out to different users, and then it will be, I mean, your brand experience will be great. So second thing is in terms of operational cost, that is a number of that is a bandwidth and CPU usage. If you have a less performant website, there are many reasons for less performant website, and one of them is it consists of a lot of resources, which are quite heavy resources, consuming a lot of memory and CPU and disk space. So make your app performant. That will save your operational usage. That will save your bandwidth as well as CPU as well as disk space. So as we can all see, there are great advantages of building a high-performance web application, but often in the real practical scenario, what happens is we always focus on the functional requirements of the project. We never look at a non-functional requirement for the project. And a reason is the marketing team or IT operation team or even product management team is not very much interested in looking at non-functional aspects of any application or web application. So it's very essential for us to get buy-in from different stakeholders that it is really important for us to build a very performant website. I mean, non-functional requirement is something which we can't just ignore. So to get that buy-in, there are different things that we can propose, and as a developer, as a program manager, or as a quality assurance engineer, you should understand these are the main advantages that as a product manager you will get from a high performance website. So for marketing team, faster site means more traffic, more visitor retentions, their loyalty and satisfaction. So that is really great for any marketing team. If you look at from IT or operations point of view, less data usage, and and since after performance you will be doing more with less consumption of CPU, memory, and bandwidth, it is always good for IT and operations because it will save their support calls. There won't be many outages. For development team, yes, I mean, eventually QA or somebody from customer support team will report problem, but it's always better to find and fix bugs early, so it becomes essential for development team as well. For quality assurance as well, I mean, when bug is found, it is really essential to reduce the time to log an issue, debug that problem, and fix and again release a new build. So to reduce that time, it's better. I mean, it's better to have this kind of evaluation done by quality and assurance team, so that they can find more and better specific bugs related to performance. And for product management team, it's always the best products are the fast products out there, like Google. If you compare, I mean, search websites, Google versus Bing versus Yahoo, the fastest is Google, and that's why it is one of the best products available in the market. So while doing project planning, always keep performance as a goal in a project document. I mean, never ignore importance of performance, and always consider setting budget for performance. I mean, budget in terms of resources, timing, and obviously money. Okay, so now let's look at how we can take your fat Superman to a fit Superman, and what kind of diet we should put him on to take him there. So web performance optimization is nothing but increasing speed of web pages, how they are displayed, how they are downloaded, And there are various aspects of performance. I mean, there are various aspects of web page loading which contributes to a performance delay or loading delays. So if you look at different factors involved when it comes to an end user experience, there are external and internal factors. So external factors which are not under our control. To give you one example is if user is using a 2G network on mobile to access website. So network is one of those factors which we can't really control as it is in the user's hand, whether he's using 2G, 3G or 4G network, or whether he's using he's on landline or Wi-Fi connection. And there are internal factors for in web application. So if the internal factors are nothing but how web pages are built or loaded. So those are loaded using the front-end technologies and back-end technologies and the servers that on which they are hosted or the CDNs that they are using. So these becomes internal factors, and the external factors is specifically in the network or from where you are accessing. So basically your location becomes one of the external factor. I mean, if you are trying to access something which is, as a cloud, it is not something which is pretty much visible to you. But if you are accessing a server which is hosted on US, then I mean, obviously there will be a huge latency compared to the server that is which is hosted in India. So network and location becomes external factors, and internal factors like application front end and back end. So we can't do much about network, but internal factors like application front end and back end we can really optimize and do a lot of things in those areas. So with new era, everybody is moving towards 4G, that is faster and faster network. So a few years back, like having a 1 GB PS connectivity was supposed to be a privilege, but nowadays it is pretty common to get 20 Gbps of internet speed. But increasing network speed, will it improve our application performance? Let's see. These are the statistics which are captured by different websites, HTTP archive websites. So what this showed us is even if you increase bandwidth, that is from 1 Mbps to 10 Mbps, the page load time is not increased linearly. So it increases. It is not if you increase bandwidth by 10 times, page load time is not reduced by 10 times. It becomes half, but not less than that. Similarly, if you look at the latency, if latency is decreased a lot, like 20 millisecond latency, the corresponding page load time is, say, 1.2 seconds. So as you can see, if bandwidth increases, page load time is not linearly decreased, but if latency is decreased, page load time is significantly decreased. So let me go deeper and let's look at this scenario where bandwidth increases and why it is not helping us with the page load time. So having a good bandwidth is very good for streaming videos, like loading a YouTube site or watching videos. It's very good for uploading a large file as well. If you are uploading photos and videos on Facebook website, it's very good to have a large bandwidth and having a good internet connectivity or network connectivity. But when it comes to page load, there are various aspects involved, specifically the round trip time, which contributes to a latency or delay in overall page load time. And it is something which we can't solve by just increasing bandwidth. We can solve that problem by reducing latency, but there are cases because of location, the latency is something which will be always there. So and the reason is how web operates is web requests multiple resources separately, and each request contributes to round trip or latency. This is specifically the case with HTTP 1.0 standard, and HTTP 1.0 standard has been used widely across multiple pages or all the websites. And increasing bandwidth is not feasible for slow connections or mobile users. So I mean, we can do to a particular. We can take it to a particular level, but beyond that, it's not quite feasible. So as you can see, changing external factors like external factors which are changed as per new era is not helping us with web application performance improvement. I mean, it is helping us to some extent, but not much. So now let's look at the internal factors, which is like web application, which consists of backend and front end and different hosting and CDNs, and how we can optimize them to get a better web application performance. So this is how a typical web application architecture look like. So there is a front end involved and there is a back end involved. Users interacts with user UIs, user interface, the different APIs. There is a metadata caching, which is like browser level caching, which is there, and front end depends on back end for getting processed data, and back end pushes or gives register or new data to front end. Back end consists of large data storage, different databases, long range analysis or processes, then data processing happening in the back end. So since there are two aspects, backend and front end, which one we should optimize? So there is always debate that whether we should optimize a front end or back end. Reason is based on recent studies or the performance golden rule. This is coined by Steve Saunders. This is coined in 2010 or 2012, which says 80 or 90% of end user response time is spent on the front end. The front end meaning client-side resources loading and rendering. So if you look at above statistics, if you take an example of first top 10 websites, and here the graph indicates the time spent in backend versus time spent in front end. The backend time is calculated using time to first byte. We will get into details of what is time to first byte. That is like that is one of the criteria which is used to figure out what is the backend response time and what is the time that users spend for load. I mean, where request is spent is loading in the front end. So if you look at top 10 website, 24% time is spent on the back end and 76% is spent on the front end. And if you take examples of almost 10,000 websites, 8% is spent on back end and 92% on front end. So as per these studies, so a page is slow or page is taking, say for example, 5 seconds to load in case of YouTube, then only 2 seconds are spent on the back end, and rest time, that is like almost 4 seconds. So 1 second is spent on the back end and 4 seconds are spent on the actual UI rendering. So 75% of time it is spent on the front end. So if we optimize front end loading, it will give us higher return of investment. So that's why optimizing front end really matters. This is as per studies in 2012. We call it performance golden rule. Typically when it comes to web application performance optimization, everyone goes for a front end optimization as it gives a higher return of investigation. But the thing is, this study is true for most of the websites having static contents. When it comes to a dynamic content website having lot of processing happening in the backend, these studies are not really true, and there are other aspects which we should also consider when it comes to optimization. So let's look at the reverse side of this coin. What about backend? Okay, so this is a typical waterfall chart which kinds of dissipates where time is spent. So here the green bars indicates where it is spent. So 4 seconds was spent in actual, that was the time spent to get first byte. That is almost like 4 seconds spent in actual doing back-end processing. Okay, so again, for few websites, this 4 seconds is quite significant, and that's why it makes sense to still fix the backend. Also, what we have observed is, yes, most of the time, the time where end user time is spent is on the front end. But if the number of concurrent users increases, like as shown in this graph, if number of backend concurrent users increases, the backend time becomes significant considered to front end time. For obvious reasons, because if number of users increases, the number of threads increases, then it will take more time CPU and it will block IOs, right? So that's why backend becomes essential in that case. So when we look at a real world web application which has a serious data models and business logic which contains like have a dynamic content, then backend performance plays a more vital role in overall user experience. Also, severity of backend performance problem under heavy load, that is more concurrent users, can be far more crippling. I mean, with front end, right? There is only one use case in which it will not be usable, but front end will be slow, but still users can use front end. But if backend is choked, then it is like, I mean, it is none of the users will be able to access web page, and then it will be very it will be very disappointing for any web application or web hosting service that their server is down. So the severity of backend performance is quite, I mean, it's riskier than a front-end performance, and then 80% of site outages are caused by failure on backend. So there are cases where outages are caused by failure in front-end, but most of the cases it is always because of failures in the backend, like the hosting service is down, or CDN is not available, or a DNS is not something which is working. So there are there is a lot of more to lose during the high traffic events. Specifically in cases of Diwali or Black Fridays, since there is a lot of high traffic going on, and if our web application is not scalable, then more users will be annoyed and they will face more problems, and the overall sales will be affected, and in turn it will also lead to bad publicity because of crashes during those events. So again, because of these reasons, scalability, availability, backend optimization also is an important topic. So it's not like, okay, there are various reasons. If we have to focus on scalability and availability, okay, go for backend optimization. If you are less looking at a user experience, your web application contents are static, go for front-end optimization. That is true, but if you look at dynamic content, it also makes sense to have a front-end optimization, because again, the contents are something which should be loaded quite efficiently. Also, if you do the backend optimization, it will lead to more saving on the operational cost of the larger project. Because backend optimization, after backend optimization, we will be in situations where we will be saving hardware and power and bandwidth usages. So, my recommendation will be don't just optimize front end, optimize both. So optimize both front end and back end. So because of it really helps if for any web application to have most optimized backend for scalability and availability, and to provide a good user experience, front-end optimization is really important. So I would like to talk about a couple of topics before we jump into actual optimization in front-end, backend. Those topics are search ranking and the HTTP communication which happens nowadays. So let's look at first HTTP communication. This is very essential for us to understand how browsers and web server communicates with each other, so that we can know or understand where is the bottleneck. So let's look at HTTP 1.1 communication. So this is which has been used across all the web pages right now. There are very few web pages or websites or web applications who are using HTTP 2.0 or SPDY. So how HTTP 1.1 works? So when we launch a website, say for example google.com, what happens in the backend is it creates one HTTP connection. So nowadays browsers are intelligent. What they do is they create multiple HTTP connections. So let's first look at one HTTP connection and what happens inside that one particular HTTP connection. As per HTTP standard 1.1, we can create one HTTP connection between browser and server, and inside that connection we can make a request for item number 1. So item number 1 can be, say for example, jQuery.js, and then backend will respond with jQuery.js as a response of hash 1. Then we have to query another so when page is loaded, it consists of lot of resources. Number of resources page is, I mean, average number of resources per page is almost like 100 resources for a normal looking visually heavy page. So it consists of lot of images, lot of JS and lot of CSS. And if you look at 1.1 protocol, how it works is kind of sequentially. It's not parallel or multiplexed. For a single HTTP connection, we will have to first make a call to get jQuery.js, then wait for response. Once response is received, then make a call for jQuery CSS, and then we will get a response. Here we can do some parallelization by having multiple HTTP connections, but there is a limit to how many connections one browser can create, because it obviously each socket connection adds to a CPU as well as memory usage. Number of socket connection a browser can create varies from 2 to 6. Like Chrome and Safari can create 6 parallel socket connections, HTTP connections nowadays. So after 6 connection to load thousands of resources, there is, I mean, still we need time in seconds, not in milliseconds. So that's why in waterfall charts we often see a long green sections which indicate long wait for downloading resources. So it's for web optimization, it's very essential to reduce number of HTTP connections. We have to combine resources, we have to use CSS5, we have to optimize number of HTTP connections that we are making. This is HTTP 1.1, and recently 3 years back, or in fact the specification was available quite a long time back, Google come up with a new protocol called Speedy, and now Speedy is HTTP2. I mean, it kinds of converted into HTTP2. Speedy actually, or HTTP2 actually handles all the shortcomings which are there in 1.1. How it works is a single connection to the server, and in the single connection you can multiplex multiple requests, and you can receive multiple responses for those requests. So in a way, we don't have to wait for first request response. So there is no blocking involved in HTTP2. And what we can do is we can actually multiplex smaller files within large blocks. So we can easily render a lot better and lot faster if we go by HTTP2 approach. We don't have to really merge requests or reduce number of HTTP responses. It will be much more performant if we are using HTTP 2.0. So all the optimization techniques which are present or given by different analysis websites are considering that we are using 1.1, which is true, and it will be true for next few years. But the world is moving towards HTTP 2. And we should have our HTTP clients as well as server support HTTP 2.0 so that it will be much more performant, and we don't have to apply any of those web optimization techniques. Also, it is a better usage of network bandwidth because we will not be sitting idle for responses. So we can prevent head of line blocking, because if there is a big web page or there is a request which obviously is going to take a lot of time, the requests which are readily available can be interlinked or interleaved. That particular data can be interleaved within those requests. Also, HTTP 2.0 inherently supports push. So server push is something which is supported by HTTP 2.0. Or we don't have to go for WebSocket or long polling, short polling, or streaming. You don't have to use any of that. So 2.0 looks like a best specification available out there, and it's very easy, and it's supported by Apache. It's supported on Apache and Nginx. So I would strongly recommend, if you have Apache and Nginx, or if you are using other servers, look for the extensions which has HTTP support, 2.0 support, and also change your front end to support all this communication using HTTP 2.0. So it works with HTTPS. So both in terms of performance and security, it's the best protocol. And as you know, performance and security plays a vital role in search ranking. So if your web page is performant, it will be ranked higher. If your web page is secure, it will be again ranked higher. So that's what Google uses. Those are the two criteria which are often used by Google. There are other criteria as well. We will look into them later. So there's one more thing we should turn off. So if you are using TLS, with HTTP2, or even if you are using TLS with HTTP 1.1, there is a vulnerability, security vulnerability called crime and beast. These are the attacks via which, even after using TLS and with having compression on, anybody can look at your traffic. So make sure your TLS compression is turned off if you are using TLS on HTTPS to have a better security in your web application. So I think many times we have this habit, if it is a compression, let's pick that, because compression will save your bandwidth, or compression will save your data usage. So HTTP is already using gzip compression. We should always use that. That is a plain text compression which is available on many websites. I believe most of you are familiar with gzip compression. And then in that case, it doesn't make sense to have another layer of compression for TLS compression. And the main reason is, yes, there is a security vulnerability available in that particular configuration. So the other topic that I would like to discuss is search ranking. So how search ranking works in Google and Yahoo. This is very important when we look at performance aspects of a web page. What websites are looking at is the time to first byte. Time to first byte is nothing but how much time it took for website to receive the first byte from server. It consists of lot of areas or lot of delays. It consists of DNS. It consists of TCP socket or TCP or SSL delays, and it also includes the backend performance delay. So websites are not looking at how much time it took for DOM to load fully or fully render the website. They are just looking at time to first byte to come up with a search ranking. So in that ways, the backend performance directly correlates to search ranking. So not just the front-end performance, and how front-end performance impacts search ranking is, if you have a better front-end performance, it will impact user experience. User will feel good about the website, and then he can obviously share or share this link or share a particular website with their friends, and then it will improve result on the search engine tracking. So that's why, if you look at search ranking also, though as per the algorithms used by search websites, backend performance is pretty good. But if you look at from user's experience point of view, since user will be actually sharing those details of websites with other users, improving front end also makes sense. So improve both front end, make a backend, it will improve your search ranking. So let's look at performance optimization for backend, and so how to tackle a performance optimization, how to do performance optimization. So there are two stages of every project. There is early stage, or I'm categorizing into two stages. First is early stage, where nothing is built. We are building something from scratch, and there is other consideration where application is out there, it is out there in market, and now we have to improve performance. So if you are building application from scratch and it is in early stage, the way to tackle performance optimization is understand the problem your application is trying to solve and what are its performance needs. Based on those performance needs, choose the right framework based on your requirements. And the most important point is follow all the optimization guidelines. I will give you links to different guidelines in this presentation, guidelines which are very well defined by Steve Saunders and all the web optimization experts based on their 20-15 years of experience in the web world. If you are building, if your product is already in production, or it's in alpha or beta stage, the way to optimize performance is measure your performance, diagnose the bottleneck, and then fix issue following the optimization guidelines. So it's kind of a cycle where it's a continuous process where you have to continuously measure, diagnose, and fix. So after an early stage where you choose a particular framework, you have to go through the cycle of measure, diagnose, fix. This can be easily achieved by doing a continuous integration of your build and running your test automation, having a good test coverage, and looking at the non-functional aspect of your project or programming. So one more important thing is avoid premature optimization. I will quickly give you one example where how premature optimization impacted my team or one of the team which I work with. So this is a very simple example. You will immediately correlate to that. So somebody who's working on the backend team and he's using Java as a programming language, um, we have to store a data for how many data bytes that we downloaded from a website. So we were using different data models to store that data, and to store the size of the file, what we use is is an integer kind of data structure. And we had a choice. That person could have gone for short, he could have gone for integer, he could have gone for long. So just to save few bytes, he went with integer. He didn't want it to use long because then it will be a bigger data structure and then it will consume memory. And what happens one day in production, we started seeing different crashes. And what was happening was the size of the file which was uploaded by one of the end user was quite high. And then, I mean, obviously we went in through that scenario and understood, I mean, what was really missing was the really understanding the problem. So what did happen is, okay, we were doing this optimization in terms of saving few bytes, but it led to more problems like production level issues which took more time for us to fix. Reason was we were not looking at, okay, this file size that we are showing, is it giving us a size in bytes or kilobytes and megabytes? What is the minimum or maximum values or limits that it will have? So based on the requirements, you should make a very good, I mean, you should really think through and take best possible data structure, or use best possible data structure, but make sure you are not doing a premature optimization because it is root for all evils. Okay, so let's look at front-end optimization, how we can achieve. So there are various aspects of front-end optimization covered in different analysis tools which are present out there. I will just go through few topics which are really important or which are recently been found. This is something which is not recently been found. It is very well known, but looking at this diagram, it will be much more clear. Browser resource blocking. As I was saying, number of requests that browser can send in parallel is limited. So Chrome can send only 6 requests. So looking at this waterfall graph, what you can see is if there is a website which has 16 images and they're hosted on the same server, how much time it will take to load those images on the web page. So ideally 1 second per image, and if you are loading all the 16 images simultaneously, we should have them ready in 1 second. But that doesn't work in HTTP 1.1 and in real scenario. What happens is at a time we can send only 6 requests, and then again we have to send 6 requests, and then again we have to send 4 requests. So in total we have to send 16 requests, which goes in like this, and it accommodates to delay of like almost 3 to 4 seconds. So because of these limitations, we should reduce HTTP requests, we should use image sprite, we should combine JS, we should combine CSS, we should use domain threading. So this limit of 6 connections per web or connection per server is a domain specific limitation. If we thread domains, then we can have few more connections, but again there is a limitation, like okay, we can have a 6 connections per domain, not like unlimited connections. So there is a new vulnerability, or you can say a new problem which is occurring we call it front-end single point of failures. What it is? So many times it has been often said that okay, backend leads to outages. Front-end will never lead to outages. I mean, there is nothing harm that front-end can cause. It will never lead to outages. But what we have seen is even Facebook and Google's and all the users like partners like Instagram, WMO, retail and media content side suffered from this front-end single point of failure problem. So what happened is if what has been happening is in all the retails or media or content sites, we are using Facebook plugins or Google plugins or Google Analytics plugin or Google ads plugin. So DoubleClick provides ads. It is a subsidiary of Google and provides internet ads for different websites. And if Facebook is down and if Google DoubleClick is down, it adversely impacts all the major websites, all the like Amazon.com, Walmart.com. You will start performance problems on those websites. Why? Because those ad websites or those Facebook or social websites, those plugins or tags are not asynchronously loaded inside a page, and if they are loaded synchronously, it will block rendering if that website itself is down. So that's why it is called a single point of failure, because of these third-party contents are not loaded asynchronously. So you can see if it is external script, it will blank everything below it in all the browsers. So if you are to avoid single point of failure, make sure you are loading everything asynchronously. So same goes for styles, fonts. You will often see that in many pages font takes longer than expected because those are downloaded asynchronously or later when it comes to page content. So when it comes to front-end optimization, it's really essential to understand web page lifecycle, how page is loaded. There are various aspects like app cache, DNS, HTTP request response processing. This diagram kind of dissipates. So as a web developer, you should know how page is loaded so that you can understand whether it is a problem due to network latency or whether it is problem due to application processing inside the web page, or it is the full app problem. So if it is a loading screen problem. And this translates to a waterfall graph. So waterfall chart, diagnosing waterfall chart is what we do when it comes to analyzing any blockage or bottlenecks. Okay, and there are various aspects like first byte, speed index, start render, page speed. These are given by user and navigation timing APIs, which most of the browsers supports these days. Ideal will be these waterfall graphs should be as thin as possible, that is the start overall load time. Also they should be as steep as possible, so that if it is steep, then it is like processed quite fast. If it consists of a long horizontal green line, those are like holdups or blockages, and those are the reasons for the performance bottleneck. There are various tools available in the market for UI optimization. The best tool that I found, which was really good, and it consists of a lot of features which are really required for optimization, is a webpagetest.org. I executed the webpagetest org performance test on techgeek.com, and this is the result that I got. I mean, there were failures in a couple of cases, and it gives it quite good results in few cases. So it consists of everything. I mean, you can get a TCP dump of everything, and there's something called Wireshark for the web, and you can load everything into that website. So Wireshark for web, again, a very good website initially. So in previous days, what we used to do is we have to send a PCAP file, and we have to tell other party that, okay, look at this in particular byte of this TCP dump, and it's very cumbersome for anybody to go through that packet capture. But nowadays, after the PCAP or the Wireshark for the web, we can just give one link or URL. We don't have to share anything. We just have to share the link, and he can visually view what we are talking about. Then there is another website, speedcurve.com. It is like a cooler version of speed webtest.org, and it in a very good visual manner, it kind of tells you where your website is doing well or bad, or and this is a commercial website. The other optimization websites are like Zoom report. It is a free report which is generated, and it gives you 5 areas or 7 areas where you should optimize your web page. There are other tools which are quite well known, Wiseflow, then Page Speed Insight. These are the plugins available in Firefox as well. There is a sourceflow.com as well, which is a combination of Wiseflow, Page Speed Insight, Page Web Test. It's a combination. It gives a combined result from different websites, and you can change this chart based on your requirements as well. So as I was saying, these are the quite useful tools like Pingdom, Browser Diet. There are rules given by Steve Saunders. Steve Saunders did a great job in defining web optimization standards or guidelines. Browser Scope or HTTP Archive gives you a good overview or good statistics of where web is going, of how it is being used. Also the clouds chart that I just talked about. If you look at the backend performance, these are the different tools or frameworks out there, and it's always a challenge how to choose the right one. So we have to make choices of web server, database, frameworks, technologies, hosting service providers, CDNs. We have to look at architectural and design of the backend application. What we should consider while doing a backend optimization, we should think about whether application is IO bound or CPU bound, whether it consists of more user request or more image data processing. What are the storage requirements? Does it need a relational database, or it consists of tons of data processing happening in the backend? What is the estimated traffic? What are the security requirements? Do I need CDN with TLS? So these are the typical bottlenecks available in the backend that we have to deal with. So the blocking operations are like file upload, image processing, sending emails to multiple users, in the data processing, which takes more than 10 to 15 seconds. So on the database side, if there are a lot of joins, if there is no caching, if there are searches on the multiple tables, it leads to a bottleneck in the backend. And the server configuration, like having a load server configuration or many processes or connections that it needs to handle, or memory leaks to a bottleneck on the backend side. How to handle those backends? So based on the project requirements, whether the application is IO bound or CPU bound, we have to make choices of the framework. Like Node.js serves better if it is a IO bound application. It provides a non-blocking IO APIs. It optimizes application throughput and scalability. And if it is a CPU bound, it's often best to go for Java or CPP based solution. When it comes to load balancing and auto scaling, Amazon does a great job there. We can have elastic load balancers with auto scaling. It gives high availability sticky sessions. It will spun instances based on the threshold defined. So again, I mean, there are various backend solutions available out there. We have to make the right choice based on the requirements that we have. When it comes to push and pull, always go for push. Use WebSocket over long polling. There is a good framework called Atmosphere. It gives you capabilities of WebSocket and fallbacks to long polling or short polling or streaming based on the browser support available. When it comes to backend profiling, there are again a lot of tools available for Java CPP. You can go for your kit. There is a visual VM or JProfiler. For Node.js, there is a Node Inspector and Vim Watch. There is also a tool called App Dynamics, which is very good for both front-end and back-end performance tuning and profiling. Again, caching, Vim, cache, Redis, Vanish helps us a lot. So for backend operations, use asynchronous processing tools like RabbitMQ or delayed jobs if it is a blocking operation. When it comes to web services, always prefer REST. Go for JSON over XML because it is faster and smaller in size as compared to XML. And when it comes to choice of NoSQL versus RDBMS database, there is a good visual guide provided considering the three criteria, which is availability, consistency, and partition tolerance. This is a very nice graph which covers different databases and which one we should choose based on our requirement. So use NoSQL database like Mongo Couch if you are looking for high scalability and availability. Go for relational like MySQL if it is a if your application has a transaction requirements consist of complex queries and joins. Always normalize database at least to one normal net form. Index the databases for frequency of access based on the frequency of access. 3 columns indexes is fine. Max go for 5, but not more than that, because it will store your database. Configure database as per your application requirements, right? Efficient database, but that is really important. Like do bulk insert, use hints, and optimize DB engine based on that. This kind of configuration, like whether to go for InnoDB or MySlam in case of MySQL. Use tools like slow query logs in case of MySQL, which will list on all the slow queries which are happening on the database, and then you can optimize them. So references for this presentation, Steve Saunders does an excellent job. Also, the Velocity conference will really help you to understand how you can optimize your web application performance. There are websites like Dynatrace, Zoom, and Google and Yahoo websites, which will again help you a lot for web performance optimization. So thank you guys. I mean, this is a webinar on web application optimization. I would like to talk briefly about my company, Claris Technologies. This is a growth story of Claris. I mean, we are now 280. So Claris is into design plus technology. I mean, we have a unique combination of one designer to 3 developer ratio, which is kind of unusual in the industry. We believe in building a very good user-centric products for our clients. We developed 100 plus products in the last 5 years. We have 30% of customers are Fortune 500 companies. We have a good revenue growth of 200% in the last 1 year. So, and we have a rich domain spread like data center, cloud with data analytics, social e-commerce, banking, and you will find more details on claris.technologies.com. Thank you all. This is my email address. If you have any questions, feel free to drop me. I will go through different questions now. It's almost 3:50, so let's go through different questions.
Yeah, thank you, Amol. Thanks for the insightful presentation. Yes, we will request you to quickly take up the questions now.
Sure. So, yep. So there is a question by Dakshesh Patel. What all changes we need to do in web application to enable HTTP 2.0? So HTTP 2.0 is a new standard which is implemented and available in Apache and Nginx. Those are, I mean, it's just like a configuration in configuration files. For other web servers, we have to do we have to do some special changes or special provisions to make it enabled. On some servers, it is not available yet, so we have to build those plugins, or we have to use some open source plugin to enable HTTP 2.0. Provide optimization techniques for JavaScript external libraries and AJAX calls. Umapati Girija. So for JavaScript external libraries and AJAX call, so if it is external library, or say for example, if you are including Java, Google Analytics inside your web application, it's difficult to control them because it's not something which is hosted by your website. So what you can do for sure to avoid single point of failure is under webpage-test.org, there is a way in which you can block particular website and see if that particular if your web page is loaded correctly or not. How that will help you is your website will be less prone to single point of failure, and second thing is using webpage-test.org, you can also analyze the external libraries or AJAX call that you are making, and it will also give you good results like whether it is optimized or images are heavy or the needs optimization or not. And you can provide those results to the different analytics vendors or the third-party library providers that you are using. Can you share some thoughts about how to reduce HTTP requests? Any optimization tool out there? Girish asked this question. So how to reduce HTTP requests? So there are very many analysis websites like webpage-test.org, Wiseflow, or Page Insights. They give you insightful data on how to reduce HTTP requests that your web page is making. Some of the optimization techniques are using sprites, combining JS, combining CSS. So there are various tools out there, and these are the techniques that you can imply. So in general, which browser is faster in your opinion for a common web user? So I would prefer Chrome, specifically. Because of many reasons. It's been, and specifically nightly build is something which you can go for, so that you can look at what is coming next. So this has been asked by Srikant. Then there is one more final question. So performance tuning. This is by Ravi Shankar. Performance tuning and optimization during the development phase itself or post-development phase, like after project is completed, need to find out the slowdown areas and bottlenecks in tuning of application. Which one is preferred? So it's always best if we can start doing performance optimization right from day one, so that we don't have to specifically spend a lot of cycles doing that later. Okay, so I would prefer the first one, and in case we haven't done that before, it's never too late to start performance optimization. So should we use jQuery as it's very heavy and contains all the, so there is another library which is a jQuery equivalent, and it is like a trimmed down version of jQuery. If you find jQuery very heavy, then you can go for that particular library. This is asked by Pradeep Chauhan. gzip compression is not working for HTTPS. Is there any alternative for that? Venkat Reddy. That is not true. gzip should work for HTTPS as well. So I was specifically asking for not disabling TLS compression in case of HTTPS, because it has a security vulnerabilities or security threats associated with that. You can go with a normal gzip HTTP based compression for anywhere. So you don't have to do compression over compressions if you are going with TLS compressions. Then Anju John asked this question: WebSocket request is better than AJAX request. So AJAX is a asynchronous request, and when so it totally depends on your application needs. If your application needs push notification or push kind of support, um, continuously polling or making AJAX requests doesn't make sense. Having a WebSocket request or WebSocket connectivity is better. Because I mean, polling also adds to CPU and memory usage. WebSocket will be much more optimal in that case, having a single connection over which you can send data. So any optimization tips for a single page application? There are various tips, various tools available for like MB Star frameworks out there. I mean, in my presentation, I have shown you quite a few of those optimization techniques. Single page applications are faster when compared to normal web application. How to exactly find out the latency problems with single page application? So number of data transfer happen over single page application is very less compared to normal web application. The reason is so it is like dynamically loaded or unloaded. So previously, when before single page application, what we used to do is we used to load an URL which leads to entire page refresh. An entire page refresh means loading everything again and again. I mean, if there is a static header, it is, and there is no change in that header, then also we were used to load that. But after single page application, you can just load a particular content of the page dynamically. It is a single URL. That's why it is much more faster, because the number of requests are less and number of resources that are loaded if something is less. But same optimization technique is almost applicable for single page application as well. So there are no specific other specific techniques which are out there for single page application. Okay. So, okay, so these are some of the questions which were asked by different attendees.
Thank you, Amol. Thanks for this insightful presentation. I'm really thankful to you for conducting this webinar today. It was indeed a great session.
Thank you. Thank you all.
Yeah, thank you.
My email address is okay. Thank you.
Sure. I would also like to thank all our participants for their support in making this webinar a huge success. The recording of this webinar will be available for you all on techgeek.com very soon. Thank you, everyone. Thanks for your time today.
Thanks. Bye.